everyone, and welcome to this session of Festive Tech Calendar 2022. This is a session where we're going to find out if we can prevent the Grinch from stealing Christmas with chaos engineering. Are you as excited to find out the answer as I am? I hope you do. Today I am not alone. With me I have Karl Cooke. Hello, Karl.
Hi, Kristina. How are you?
I'm great. How are you doing?
Very well. Very tired with a newborn, but that's life.
Yeah, I hope we can get our mood a bit more festive tonight.
Yeah. So I'm really disappointed in myself that I didn't live up the expectations around the festive apparel, but it looks like you're making up for us both.
Yeah, it. I don't think that would be a big problem. I hope it's enough festivity in my background, and I also acquired Grinch ears for this session today, and I also have a Grinch T-shirt, so I'm fully packed.
That's awesome. That's awesome. Before we move on, do you want to tell everybody who you are and what it is you do?
Yes, obviously. So my name is Kristina Devochko. I am based in Oslo, Norway, and am working as a software architect at Admin Control. I am also an Azure MVP and a relatively fresh one. I have gotten my MVP in September. Woohoo! So I'm still getting used to being an MVP, and it feels really awesome. Yeah, and I just love contributing to the tech community and talk about all things cloud native. And
That's awesome.
what about you, Karl?
So, for people that don't know me, although I'm very noisy on social media that might know me already, I'm Karl Cooke. I'm also an Azure MVP. I work just recently started with Avanade as an Azure architect. So, it's going really well so far. I'm really enjoying being there. When I'm not doing MVP stuff, I'm a LinkedIn learning instructor. And you can check out my new course, which released 2 days ago on private access in Azure networking. So check that out, LinkedIn Learning, when you get a chance. And I also enjoy most things Azure, but particularly the cloud native space. So looking forward to getting stuck into protecting Christmas from the Grinch.
Awesome. I'm also really looking forward to taking a look at your learning course. It looks extremely insightful and packed with valuable information. So
Thank you. Thought
awesome.
would plug that while I was here.
You got a chance, you used your opportunity. So
Yeah, yeah,
perfect. All right. Before we get to the content of the session, I think it's important to mention a great initiative that is being supported by Festive Tech Calendar organizers this year. And this is the opportunity to raise money for Missing People charity. And here on the left-hand side, you can scan the QR code in order to also contribute to this amazing initiative, which really can make an impact for some of the families. So kudos
yeah,
to the organizers.
yeah. Well done, Festive Tech Calendar organization team. It's great charity, important to support them. So if you can, I know it's difficult for a lot of people at the minute, but if you can, scan that QR code and donate. Thank you.
Yeah, thank you. All right, so let's get to it and try to find out if we can prevent Grinch from stealing Christmas in Kubernetesville. But before we get to the action itself, I think it is important for the audience that may be beginners in chaos engineering or haven't heard or used it before. I think it would make a lot of sense for us to maybe start out by giving a brief introduction about what chaos engineering is. So, Karl, what can you say about chaos engineering? It sounds really cool, but what
So
does it actually mean?
it really sounds like a fun concept, doesn't it? So Microsoft's well-architected framework defines chaos engineering as a methodology that helps developers attain consistent reliability by hardening services against failures in production. So while that's all very well and good, if you think of chaos engineering as a way to introduce chaos by deliberately causing faults and failures within your system, within your application and the platform that it runs on. So the goal there then is to allow you to observe, monitor, and respond to the chaos that's happening, because quite often in as what you'll see in a little bit, quite often in failure scenarios where you're invoking disaster recovery or invoking business continuity plans, it is all very fluid and it is all very chaotic. So using chaos engineering or adapting chaos engineering is a way to help your developer and platform engineering teams to get used to what failure looks like and reacting to failure in a fast way, and also perhaps the ability to automate some failure scenarios as well to make life easier in the event that something horrible does happen.
Mm. And that is very, very well said. And I think this is a great opportunity to get more confidence in your system and to get more familiar with your system and its behavior. And this will really help to kind of shift left on detecting issues as well as early as possible.
Completely agree.
Awesome. And this, as you can see on this funny meme here, it is also based on the scientific techniques. So it was previously known like as part of the physics science, I think, and then out of there, it kind of got monetized into the world of IT and tech, and has really taken off recently.
It's awesome. And the comic strip is funny, but I don't recommend taking a blowtorch to any data centers, servers, or public cloud environments anytime soon.
Or anything else for that matter.
Or yeah, well, we don't know people's lives. Blowtorches look like they could be fun, you know.
True that. But at least if you don't own a data center, you shouldn't probably take a blowtorch with you if you're gonna go there.
Yep, true.
Cool. So,
Okay, so can you talk to us then, Christina, about the main principles of chaos engineering?
yeah. Wherever there is a specific domain, you can often see that there are a set of principles or set of best practices that can help you succeed with adopting that technology. Like also chaos engineering, the same here. So, what are the best practices? What are the goals of adopting chaos engineering? And I think the main principle that you can see on the top of this slide here, it's if we can apply it to today's session, where we try to make it a bit more gamified, a bit more approachable about Grinch and stealing Christmas, trying to destroy the system so that your platform team need to cancel Christmas for themselves and get back to work to try to fix the systems that are suddenly in a disaster state. I think the principle here applies very well to this situation. So the harder it becomes for the Grinch or whatever disruptive event out there, the harder it becomes for such events to disrupt the steady state of Kubernetesville, which in your case may be your systems that you are maintaining and operating. The harder it becomes, the harder it is for a Grinch to steal Christmas and destroy the festivity in Kubernetesville, the more confidence we or you have in the behavior of the system, in its stable state, in that the system is healthy and you can feel good and peaceful about going on vacation and enjoying Christmas to its fullest. So all those principles base themselves on this one. So what are the different practices that can help you to get more confidence in that in the state of your system? And there is a website that you can see in the bottom there. It links to the web page that describes, I think it's like 20 languages it is translated to. It describes all these principles of chaos engineering in more detail. But to mention briefly, you normally start by building a hypothesis around the steady, healthy behavior of your system. So you kind of make a baseline of what defines your system as healthy, as stable. And then once you do that, you start you start creating experiments from the smallest and trying to expand that. And it's important to kind of apply the second principle there when you work on those experiments, and it's about varying real world events. So for instance, you may have different events that can go wrong. There can be outage in a region, like we will maybe see during the demo later. You can have software issues in your software, in your applications. You can have issues in your hardware, or you can have a huge load or a DDoS attack, right? So you would need to have different experiments to kind of make it variable, to test your system from the different angles. And then the third principle is what chaos engineering really tries to promote, is that if you think about it, we have development environments, staging, pre-production, production environments normally, and then they may deviate quite a lot. And it's not 100% guarantee that if your experiment succeeded in development, it will not cause your system to fail under the same circumstances in production, because the amount of data may be different, the amount of network traffic, the amount of load on the system can be different. And the way the users are using your system can be different as well. The configuration can be different. So if wherever it is possible, and many larger organizations are practicing it, you would want to run experiments in production. Maybe not start with that while you're just getting hands-on skills, but at least as you evolve, as you get more experienced with it, try to run those experiments on the system which is as close to the real life system as possible, because then it will give you much more confidence in that those experiments actually will mean that your system is stable and resilient enough. And lastly, it is manual, running such experiments manually can also cause human errors. Like anything else we would use and try to do manually, there is a high risk of doing manual errors, and maybe it will make it hard to roll back in case you try to implement this manually. So try to work towards automating experiments in this case as well, to run continuously. And also minimize blast radius. So normally you would start with as small experiments as possible, expanding them based on the findings. If there are no findings, you would want to have a bit wider experiment, testing a bit more of the resources. But also when you are testing in production, you also need to be really, really careful so
Yeah.
that it will not affect the
So,
users.
so causing a failure in production used to be a resume generating event. Used to have you back on the job boards very, very quickly. But this,
Mm.
in my view, is about adopting the attitude and the outlook that chaos or bad things or failures, they do happen. So it's about
Mm.
learning as an organization, learning as a business, not just the technical functions, not just your developers and your platform engineers, but learning as a business how to react to those failures and how to maintain availability of your application and your processes and all of the stuff that goes with that, because failures do happen. And they shouldn't be in the culture that we're now embracing, the DevOps culture and the platform engineering culture. They shouldn't be resume generating events anymore. We should be talking about blameless postmortems and things like that. But chaos engineering is about embracing the fact that problems do happen, failures do happen, and it's about learning as a team, as an organization, how to react to those.
Absolutely. That's it has so much to say about the culture. And this gives you also an opportunity to test not only your skills, but working as a team, working as an organization with handling those errors, and in a more controlled manner, in a controlled environment. The better prepared you are, the better it will go when things
Yeah.
actually will go wrong, and they will go wrong at some point. So yeah, I think we've been through all the principles. So
Yeah.
if we move on to like the benefits, because it all sounds really good and really scientific and really important, but like if we go try to look into actual benefits. So Karl, from your perspective, like what do you feel are the benefits? Why should anyone else listening to us, why should they bother about chaos engineering?
So I alluded to those some of those a few moments ago about not generating doing a resume generating event and learning agility and responsiveness in the event of a failure. But like the slide says, we're trying to boost system reliability. We're trying to boost availability. We're trying to keep that. We're chasing those 5 nines or whatever it is for availability. We're or for uptime. We're wanting to learn how our application ticks, how our platform ticks, and making sure that we have, like the slide says again, the practical, the hands-on experience of how to react in a disaster. You're gonna once you learn how to react in a disaster, you'll then learn how to automate your reactions and how to make everything as smooth and efficient and as agile as possible. So it's going to improve again, going through the slide, it's improving your observability. So what you understand or how you understand your platform and how it reacts. So the more you experiment in the chaos engineering area, the more you'll see the tells or the information that gives you an early warning to something about to go wrong with your system. you know and one of the most important things is it brings your team closer together. You're boosting confidence by almost gamifying, like Kristina said earlier, the practical skills around managing when stuff does happen, and it does,
Mm,
and it will. We're not going to pretend that like in years past where the systems are infallible, that they'll not fall over. They will, and in the
mm.
public cloud they do, and quite often, regardless of what public cloud you're running in. So it's important to build that team and build those skills together so that you can react to that. And finally, how cool would it be to be able to add chaos engineer to your LinkedIn profile, your CV?
Yeah, or add it as a skill on the LinkedIn profile. I think you can do
It's
that.
true. Yeah, I think after this session, I'm going to add it to my LinkedIn just because it's cool.
You should do that. Maybe I should add it to like the title, the overview
Yeah.
over my profile. I'm looking forward
Christina
to
Devo-
finding an assessment.
Christina Devochko, chaos engineer.
Ooh,
Do it.
disrupting disrupting production systems with chaos. Ooh, sounds like a new title for me.
I like it. I like it.
Awesome, yeah. Yeah, but I think those are very, very good, good and important benefits of gas engineering. And one thing I got to think about, like while you were talking about this, Karl, is like if you were to pitch this to business folks in your organization, I think a really important point here is what the cost is when the system gets disrupted, when the system or your applications go offline or are not performing enough. If we think about the SLAs, about every second or every minute of your system being offline, depending on the criticality,
Yep.
that would be a huge cost potentially.
Yeah. So I mean, and on that same vein, on that same thought, you're losing potentially losing revenue from customers not able to access your systems. But some customers or some organizations operate in industries where there are financial penalties
Mm,
for their systems not running. So while you may be losing revenue, you may be losing X, Y, and Z, you could also be getting penalised you know, um, by your industry because you're not up and
mm,
running the agreed amount of time. So yeah, it's
mm.
definitely worth investigating and investing in chaos engineering, in my opinion.
Yeah. And it affects the reputation as well. I mean, from time to time, or like quite frequently, I see all these headlines in the newspapers like, here the system stopped working, here this affected this and this industry. And it's like, yeah, it's not good if this
No.
happens in production. So, chaos engineering can really help mitigate that as early as possible. But now we are getting closer to the demo, and I think it's a good idea to show some of the tools in action, like how you would approach this by testing your systems by running chaos experiments. So on the left hand side, we can see like the official production level tools that you could look into and adopt. And many of you might have heard about Chaos Monkey, which was kind of the first chaos engineering tool that was created by Netflix. And the others are kind of those that followed and evolved and built upon what Chaos Monkey was used for by Netflix, and also by the community when they open sourced it. So you can see there Gremlin, Litmus, Chaos Toolkit, Chaos Mesh, and actually Azure Chaos Studio, which Karl will be showing in a while, which also builds upon Chaos Mesh. So it kind of abstracts Chaos Mesh and makes it more user friendly and easier to start working with, even by defining experiments through Azure Portal. And on the right hand side, you can see the fun way of doing chaos engineering. So if you need to demo or you need to pitch this to your engineers or SREs or whoever of the techies that you would like to show it off to and introduce the chaos engineering concepts and kind of trap their attention into it, then you could use these open source tools that are really amazing. I'm impressed by the fantasy of some of the open source people out there. So there are Cube Doom, which is kind of based on the game Doom that some of us may have played. And then
A
you
long
have
time ago.
Wacko. Yeah, me
Yeah, a
too.
long
That was
time
a
ago.
really long time ago, yeah. But if you need, like to get that nostalgic feeling, you could try Cube Doom, just a bit more real life, and targeting a real Kubernetes cluster. And then the one under or below that is something called Whack-A-Pod, also, based on the very known game Whack-A-Mole. And then you have like KubeCraft admin on the right bottom side. It's like based also on a la Minecraft.
Yeah.
And on the top is Cube Invaders, which is coming from or inspired by the Space Invaders game. I have used it several times, and I think it's just awesome. I love it, absolutely love it. I've done demos with it in enterprise context, and I need to say that it really got people to focus and kind of get really interested in chaos engineering and what it is. So I will
Oh,
also show it in a while.
that's awesome. Just to add there about the you have your official more enterprisey stuff, where Chaos Studio and Chaos Mesh and Toolkit and that. But on the other side of the screen, like Kristina says, it is a lot of fun, and quite often you'll have to evangelize and talk about chaos engineering to try and drive adoption in your organization. And what better way than using this sort of game tech, the Cube Doom or the Cube Invaders, to get people bought in? Yes, it's a bit of
Mm,
fun, but it's the hook that maybe you need to have a wary organization or a wary developer team buy in or buy into what's going on. So really cool technology
mm,
and really cool use of tech there.
definitely. And we know how hard it may be to keep focus if you have a very, very serious black and white presentation, very serious demo. So maybe this can, get it a bit more energizing for the audience
Yeah.
as well. Awesome. There are, of course, many, many more tools, and we have some materials that we will share with you afterwards where you can take a look at it. These are just some of the tools we decided to highlight in this session. All right. So the main question of this evening: will we be able to stop the Grinch from disrupting Christmas in our Kubernetesville? What do you think, Karl? Will we be able
I
to do
think
that?
I think it'll be a close run thing, but I think we'll get there.
Yeah. I think we will be kind of the Grinch and at the same time learn from it and show how you would work with the findings that you can discover with these tools.
Yeah.
So shall we start with the fun way or with the serious way? What do you think?
I think we should start with the fun way since you're already sharing your screen. You get to be the
Yeah.
the the, the fun demo today.
The fun demo, yeah. I think the serious way can also be very fun since it's such on a larger scale. But we will start small, like with the chaos engineering experiments, and expand. All
Okay, let's
right.
go.
So let's start the fun. So let me just hide this presentation here. So I have suddenly a lot of tabs here. But as I mentioned today, I would like to show you a simple way to start with chaos engineering with the Cube Invaders tool. So what I have here is on the left bottom side, I have my mission critical application. It is called Neon Cat, and it is deployed on an AKS cluster. And it has a really irritating music, so I have turned it off for the purpose of not getting anyone crazy here by the end of the evening. So we will just enjoy the animation and see if we can bring it down. So as a beginner in my Azure Kubernetes service cluster, I have created or deployed this application with a single replica. So if we try to search for it in my cluster with kubectl get pods, and the namespace is chaos neon cat, we can see that I currently have a single replica here, which is running. So that's good. And that we can see here. So let's put it on to refreshing every second just to see what will happen with this application once I start disrupting its state. On the right-hand side, I have my Cube Invaders application up and running. So as I mentioned, it is based on the very well-known Space Invaders game. So here I have aliens, and aliens in this case represent pods. But I get also to target the nodes if I want to. So by clicking H for help, I get some options. So for example, if I want to include nodes for targeting, I can click C, and then it says here what the latest action has been. So as you can see, latest action show nodes, and now nodes pop up here as well. So I can target and try to disrupt both pods and nodes, or just a single one of them. I can also change namespaces, and this is something that you can define when you deploy Cube Invaders with Helm. You can define a single namespace or a collection of namespaces that you would like this application to target. I have deployed it to target a single application because I have a single node AKS cluster where my control plane is running, and I would not want to target any of the pods that are running in the control plane, obviously, or the pods where Cube Invaders is deployed for that matter. I still want it to be up and running. But in the long run, you can target multiple namespaces. So you get also an opportunity to shuffle, or like to let it be static and just target them yourself like you want to. But I would like to start with the pods. So I will turn off the possibility to target nodes to make it a bit easier. And now let's see what will happen once I start targeting my application pods. And in this case, for every time it hits the pod, or the alien in this case, it will bring the pod down. And then we will see with a single replica how many attempts do I need to actually make my application offline. So let's start. Pay attention to this. Oh, that didn't took long. I just wanted to say pay attention to this amazing Kubernetes icon here. And then you can see that with a single replica, it went out almost instantly. And this is kind of a good start to build up on making your system, your applications more resilient. So what did it
Mhm.
actually mean? Well, it means that you can't get far with a single replica because it can die
Yep.
at any moment. And if you have a heavy application, which takes time to warm up, if you have a single replica, then it may take quite a long time before your application is up and running, which is not very good.
No. So
So,
what would you do? So you're running a single replica right now.
yeah,
What do you recommend then to protect yourself against single pod failure or single instance failure in this case?
that's a very good question. How can we mitigate that? And the step number one would obviously be to create more replicas. So if we take a look at the AKS baseline recommendations and the AKS best practices, normally you would want, depending on which environment you're running in, but you would want to have at least 2 replicas of your application up and running, because if one goes down, then you always have the other one up and running, and that also will give time for a new replica to come up, to warm up and become ready before, for example, the second replica dies as well. So if we would do that now, we can also see that by, if I will quickly just edit the deployment here to increase the amount of replicas, chaos neon cat. Let's see if I find in my deployment YAML manifest, I can find the replicas here, the replicas property, and change it to 3 just to illustrate, and then save it. I can see that the deployment has changed, and you can see that now it's 3 aliens that popped up here. So it's,
Important to
let's see.
note at this point as well that if you're using Kubernetes or Azure Kubernetes Service, you're probably well familiar with stateless applications, or for managing state within applications that are running on Kubernetes. So we're assuming and glossing over the fact that there's a lot of groundwork and preparation that you need to put into building your application so that it can run across multiple instances. But the benefits
Mm,
that you get by making your application as stateless as possible and to be doing what Kristina is showing here are,
mm,
are, are endless and numerous to your application and your organization by putting in that development effort to make your application as stateless as possible so that it runs across multiple instances, where the ultimate goal is you could lose an instance or two and still
mm.
be operating.
Yeah, and that's the main concept. That's kind of, if you start taking any Kubernetes course, right? One of the first things you get to hear is that pods are ephemeral, which means they can die at any moment, and you just need to build your applications to be prepared for that. That
Yep.
whatever amount of pods can die whenever. So you need to be able to handle that. So yeah, so if we, for example, would try to target those guys now, you see, of course, I may. It will become much harder for me to, like, start clicking here, and I have a pretty lightweight application, so like to bring it down is much harder now,
Yep.
and it comes quickly up. And as you can see also on the left hand side here, it's terminating, creating container, putting it up. So it shows, also illustrates that this is a good start. And I have a single node cluster, but a step over that would be to also have an AKS cluster or a Kubernetes cluster with multiple nodes, where you can evenly distribute the replicas of your applications on different nodes. Because if I would start here by targeting nodes, then if a single node goes down, you would still, then all the replicas, all the applications running on that node would go down. And if you have multiple nodes and you have replicas of those applications deployed on those nodes, you will handle the situation of a node failure. Your applications will still be up while you are handling the scaling or self-healing and creating a new node instead of the one that failed. So since I have a single node, it will be very interesting what we can be able to achieve here. But before I try to target it, I just wanted to show that under the menu here, you can also get some options like running a cube linter to get some information about the improvements you can do to your templates. But you can also define how you would like to stress nodes, because in the background, Cube Invaders, for kind of targeting disrupting nodes, it's using a utility called stress ng, and it is very known in the world of Linux. It is a utility that helps you to stress and load your system. So you can define, there are a lot of options if you check the man page for that one, but you can like define how much CPU do you want it to target, how many killers or like how many stressors do you want to target it at the same time, how long they should target your server or your node in this case. So you can define it here. So here are some default options, and you can adjust them. So for example, if I would want it to stress for 20 seconds with 4G, and if I would like to have, like, I don't know, 20 stressors at the same time, then I could do that. I'm not sure what we can achieve here. It's a bit different all the time, but what I will do is that I will disable pods, and I will just target the node forever. Yesterday I was having a lot of fun with it because suddenly it just stopped responding at all, and everything just went down. And I need to show you this because this is also like a single node, which means that I have my Cube Invaders application, I have my control plane running on that poor single node, and if I target it long enough, I think it will really suffer from the out of memory exception, because it also targets the CPU and the memory at the same time. So my node is very cheap, you can say, one of the cheapest that was possible to choose. So it does not have much, but we'll try to target it a bit and see, just for a few more seconds. As you can see, there is a lot of chaos happening on
And
the left-hand
the
side.
Nyan cat is certainly slowing down with all that's going on the cluster.
It does, doesn't it? But it's still able. I mean, it's refreshing, like but the node is pretty, like, also the self-healing capability here, because when it will see that it does not have enough memory, it will start pending the pods. As you can see, there are more pods getting a pending state, which means that once it reaches this memory consumption limit, it will just will not schedule any more workloads. So they will just queue up in a pending state, and it will not try to deploy anything else, because it will try to self-heal the existing workloads to not take them offline. Well, now I have targeted it for a while, but as you can see, it has shown to be pretty well. So if we go and take a look, get pods in all namespaces, yeah, we can see there is quite some chaos here. Not enough probably to bring it down, but you can, as I said, also adjust. As you can see, the memory here is definitely overcommitted. The CPU
Yeah.
is overcommitted, so it's not in a very good state right now, though it still tries to keep up the applications up and running. So if I would also show you last thing by describe note. Maybe we will also see this information here. False. Yeah. Let's see. Kubelet is down, as you can see here. So it actually was having some issues already. And you can see obviously that it is overcommitted, but it has stayed quite nicely for a while.
It's
But
quite
this is
impressive as
something,
to how much
yeah,
that's kept being okay while it's being effectively tortured in the background.
Yeah, and this also illustrates this amazing self-healing capability of the Kubernetes. One of its strongest reasons for why many people or like many organizations are adopting it. Yeah, I think that was the fun way that I wanted to show you. So there are in the resources we're gonna share. There are the Terraform templates and the commands that you would need to use to set it all up from scratch with AKS, Kube Invaders, this demo app. So do ensure to test it out for yourself and play around with it and have some fun as well.
Awesome. So, what one more thing I'd like to? So, we're talking about increasing the instances, or sorry, the replicas of your
Mm.
application to improve reliability and availability in the event that something does go wrong. But can you talk a little bit about how you would? Is it pod affinity or node affinity or anti affinity? How you would use that sort of stuff to ensure that you spread your instances of your application or your replicas of your application out around multiple nodes?
Yeah, I think that's there are several things you can actually do here to kind of ensure that your applications are evenly distributed across nodes, and also if there are any node image upgrades that are happening, that you could do it in a graceful way with
Mhm.
zero downtime, because that's also the goal. That's also what you would like to achieve by running your applications on Kubernetes, to also upgrade with zero downtime. That's kind of the ultimate goal for many organizations, I think, to be able to have a daily or like releases multiple times a day. So here you could also use the affinity and anti-affinity, which will help you to define, like if you want to schedule your pods on different nodes or not. You can also define the operating system that you would like these pods to be scheduled on. For example, if you run a combination of Windows and Linux nodes, you may have applications that can only be scheduled on Windows.
Mhm.
So then it's on Windows nodes. So then it's also important to define that. And another important point is to use pod disruption budgets, because when you have multiple replicas of your application, you could utilize this great Kubernetes object called pod disruption budgets. There you define that during disruption, how many instances of your application do you want to be up while the rest is being offline. So, for example, if you're running node image upgrades, you would need to migrate your application to this new node at some point, and then you will need to bring down some of or the application on the node that is being upgraded. And if you have like 6 replicas of your application and you use pod disruption budget, you can, for example, define, I want at least 3 instances to be up and running. So when you run the upgrade on the node image, it will create a new image and a new node. It will take 3 replicas to this new node on the newer version, and then it will still keep the 3 other replicas up and running on the previous node. And once the 3 replicas on the new node are ready, up and running, ready to receive traffic, then it takes down the rest of the 3 replicas on that initial node, because then it has this at least 3 running on the new one. So it's a really powerful resource, or also Kubernetes object to use, especially in production.
Awesome. Thank you.
Yeah, I think now it's time to get more serious, to get more to the serious business and take a
Yeah.
look at Azure Chaos Studio.
Okay, so I have the less fun demo. So to round out the session, so let's just add my stream in. And as you can see, I'm on the Microsoft Docs, or the learn.microsoft.com as it is now, and on the what is Azure Chaos Studio page. So as Christina mentioned, There are plenty of links and information in the Git repo or the GitHub repo that we'll share along with this video. So do check that out, and do use the Terraform and the YAML files and all of the collateral to help you run these tests and these experiments yourself. So just a quick look at what Microsoft says Azure Chaos Studio is. Managed service that uses chaos engineering to help you measure, understand, and improve your cloud application and service resilience. So that's just a very intelligent way of saying what we've been saying all along. It's about improving your observability and your knowledge and your reaction times and your automation to make things as resilient as possible in the event that something horrible happens. So it's important to note Azure Chaos Studio is in preview. So fair warning. Usually we would suggest that preview features would not be used in production, but in this case, we're wanting to cause a bit of chaos, so I think it might be okay. Just don't tell them Karl said so, so it'll be okay. Okay,
You have it on tape now.
Another document that I have open is the Chaos Studio fault and action library. So as I show you in a second, Chaos Studio has an awful lot of experiments, as they're called, as to how to disrupt your application. So as you can see, a time delay, pressure on the CPU, physical memory pressure, virtual memory pressure, and then let's just scroll all the way down here a little bit. You can see scale set instance shutdown and Cosmos DB failover. So it's not what we're talking about here is not just for Kubernetes. Chaos Studio can get involved and plug into so many different resource types in Azure. So in the subscription I'm about to show you, I only have a few resources, but the more resources you have in your subscription, the more Chaos Studio will show you its ability to get plugged in. Its ability to get plugged into. Sorry, let me just quit that. Your ability to plug Chaos Studio into multiple resources and resource types. So it's not just about Kubernetes. It's not just about that cloud native tech. It's about anything. It can disrupt NSGs. It can disrupt VM scale sets, databases, network functionality, the works. So before I show you more in the portal, I'll drop over to my PowerShell window and just show you how I have my cluster set up. So I have two identical clusters for this demo, one in North Europe and one in West Europe. Don't tell Pixel Robots that I'm borrowing his Oh My Posh theme. I haven't quite got creating my own yet. So what we're going to do is we're going to show you all of the pods in our cluster with kubectl get pods and -a for all namespaces. And I'm also cheating. I'm not using the new kube login functionality, which I should do. As the warning suggests, it'll become unavailable to use my method in version 1.26 and above. So do get used to kube login before that happens. So as you can see, to support Chaos Studio, we need Chaos Mesh in your Kubernetes cluster. And that's what you can see here in the Chaos testing namespace. Okay. And there are, as Kristina spoke about in her demo, we have 3 replicas of the controller manager. So while I only have a single node cluster running in North Europe, there are 3 replicas running here. And if I had a multi-node cluster, they would be spread out over multiple nodes. And then just like Kristina, I have my Chaos Nyan Cat namespace with the single pod running there. I'm not going to adjust replicas for this demo because what we're talking about here is more architectural decisions and design decisions for standing up multi-region Kubernetes clusters and how that might look. But in most production use cases, you would have your multi-region Kubernetes clusters. So one in my case in North Europe and another in West Europe for this demo. But then inside each of those clusters, you would have your multiple replicas. So you can tolerate local failure as well as regional failure in your design. Let's hop back to the portal and we'll have a look at the Chaos Studio. Okay, so in terms of targets, so targets are the resources in Azure that you're targeting with Chaos Studio. As you can see, because I've got quite a reduced number of items in this subscription. It's only showing you a small amount of those, okay? With the Chaos Studio Kubernetes clusters and the virtual machine scale sets, okay? And as I said, just like we mentioned, it can show you the network security groups as well, okay? So forgive my 4-year-old for joining us for our festive session. I'm going to continue as if she's not there for the moment, okay?
That's how it
So,
is. No worries.
In experiments, we have an experiment called AKS Chaos. And before we click into that to show you what's happening with it or what it's going to do, I'll show you how we can create experiments, okay? So you would just check to create an experiment, select your resource group and your region. So the regions are limited because this is still in preview. We'll just select West Europe and we'll just call this Test Chaos. If I could spell, that would be useful. For the entire world that might see this, this is my daughter, and she just wanted to join us in the video today. So, as you'll read in the documentation that I was showing there, your experiments are designed into steps, and each of those steps has one or more branches. So you can have multiple steps in an experiment, and then you can have multiple branches within each of those steps, okay? So just to show you the breadth of this tool, you can choose add action. So you can add a delay where it's adding latency and just making things a bit slower. Or you can add a complete fault. So we'll just choose fault here, and then you can select from a drop down. You can see the Chaos Mesh integrated ones, where DNS Chaos, Kernel Chaos, Pod Chaos, which is actually what we're using in the experiment that I've already created, down to CPU pressure, kill process, security rule issues, and then to if you really wanted to pull the rug out from under your cluster, you could just force a VMS or VM scale set shutdown as well. So we're not going to create anything here. We're going to go back to the experiments. And in the AKS Chaos, you can see I've been playing with this already. Okay. And what this is going to do is, we'll hit the edit button. What this is going to do is it's targeting a specific region for me, and it's targeting a specific namespace. But what it's going to do is it's going to destroy and disrupt the pods that are contained within this namespace. Okay, and as you can see in the target resources, I'm just specifically targeting my North Europe cluster. Okay. So let's just go back to the chaos experiments. We're going to run this experiment in just a moment, but what I'm going to show you is I'm logged in to the same webpage with this Nyan Cat, minus the music. I quite like the music for about 30 seconds each time I look at this, but I've been playing and experimenting with this for a bit today, and I think I would have been driven mad by the music by this point. So thank you, Kristina, for turning that off. So the IP address ending in 115 is our North Europe version of Nyan Cat, and then over here, ending in 169, is our West Europe version of Nyan Cat. Okay, so what we're going to do is we're going to go back to our experiment, and we're going to hit start. So what that's going to do then, it goes through a few stages, pre-processing to start with, and then it'll eventually go to running. And then what we'll notice is that we will lose our North Europe version of our Rainbow Cat or Nyan Cat. So we're waiting to start. So what I'll talk about maybe I'll talk about it right now. So now that that's running, if we go back to our PowerShell window and we'll rerun that same command, you can see it's restarted that pod 14 seconds ago. So about the same sort of time, give or take a few seconds when I clicked the button in the Azure portal. So now if I go back to the portal and to our Nyan cat and just hit refresh, you can see that that pod is now down. So if we were relying on a single region, then our application is down. If we go to our West Europe region and we'll just hit refresh, so that's a hard refresh there, that's still functional. So that my chaos experiment is only targeting one of my regions currently. So one of the good things about Azure and designing architecture for this sort of stuff is that you can design a multi-region architecture. When you have your same sort of stuff and same sort of technologies and ways of working and development techniques that we talked about during Kristina's demo about making it as stateless as possible, asking that it cope with running across multiple instances and replicas, that same skill set and that same technology can be used across multiple regions. So what I effectively have is a cluster running in North Europe and a cluster running in West Europe. And as you're about to see, they're both as you can see, they're both running the same application. And if I put Traffic Manager or another load balancing technology in front of those, so global load balances in Azure are Traffic Manager and Azure Front Door, and they help with regional failover. So what we've got here is we have our two Kubernetes clusters running the exact same application. One of them is currently dead and faulting, but Traffic Manager, as you can see here, is configured to point at both of my clusters. My North Europe cluster, which is the one that is faulting currently, is the primary. We're in priority routing mode, which means it pays attention to these priorities. Number one, it will attempt to go to number one first, and then it will go to number two if number one is degraded. Okay, so number one is degraded, which means that it will be bypassing this altogether and going to West Europe. So in this window, you'll see that I have my Traffic Manager open and pointing just to the Traffic Manager profile. So if I do a hard refresh here, you can see that that is still running, which means Traffic Manager knows about my two back ends. Excuse me. Traffic Manager knows about my two back ends, two back end clusters, but it's intelligent enough to know that in my primary cluster, which is the North Europe one, as you can see here, is failed, but it knows due to its configuration in priority mode that the next it goes then on to the next endpoint, which keeps our application up and running. So while it might be more expensive, if your application is mission critical or if your application is business critical, then utilizing multiple regions with load balancing technology is a really good and smart architectural decision to ensure as much uptime as possible. Okay. One of the other things that if you were to do chaos experiments, and as I suggested earlier, we'll just go back and we'll have a quick look before I wrap up our demo. But one of the experiments that you could have done was, one moment, we'll just get to the right place. I don't care what that's called. One of the things that you could have done was to add latency and delays to your application. So adding network chaos or HTTP chaos or IO chaos would increase the latency of your application, so it would slow down an awful lot. What you can do with Traffic Manager is you can change the routing method from priority to performance. And what it does then with performance routing mode, it will hit the target or the back end that is showing the lowest latency. So you're always hitting the best performing target based on your geographic location. We can skew that experiment or we can skew that choice by increasing the latency artificially. So there you go. That was quick, and thank you for my daughter for coming in the middle of that to show herself to the Cloud family. So Merry Christmas from Miss 4. So
Yay.
so yeah.
Yeah, I think this illustrates it really well with geo-redundancy and the importance of that, especially for like mission critical applications and like if you have SLAs, right? Having this is important. Like from your experience, how often do issues or failures with specific with data centers or specific regions may happen? It's not like they never happen, even
No,
though.
it's not like they never happen. And what I'm using in that design, and yes, there are several best practices that I would be following per region in a production environment or with one of my customers, but using multiple replicas and protecting against local hardware failures as well as regional failures. But it's quite, I mean, multiple things can happen in a region.
Mm.
Recently, we've had instances where Cosmos DB has went down. Where, if you remember, a few months ago, there were a bad update to the Ubuntu
Oh yeah.
node image, which caused DNS issues. So while that ended up being a global issue, if you have these region isolated issues, then having those secondary regions and having something like Traffic Manager or Front Door in front of your application, designing for failure, architecting for the fact that chaos will happen,
Mm.
will benefit you in the long run. So what we showed in the second demo was that I could effectively kill my North Europe region, or let's just say there was a massive issue in North Europe. It just stopped working. Network. Someone put a digger through or a JCB through the fiber through all of
Mm.
those network cables that go into the North Europe data center in Dublin. And what we showed there was that application can still function
Mm.
based on based on thinking in advance and designing for failure in the public cloud. Your application will still be able to run and tolerate even up to regional failure.
Mm. Mm. Yeah, that is a really great illustration of how you could mitigate issues like this as well. And I think one important thing maybe that's worth mentioning, like what you have seen, Karl, regarding the access control for those experiments. Like what would be important when you start setting those up, and like for those experiments
So
having enough permissions and
thanks
all.
thanks for mentioning that. So it's important to just read the docs. So read the Microsoft Docs and do exactly what it tells you.
That
Don't do
was
what
not
I
the
did.
point.
Don't do what I did today and scan the docs and then go off and do it your own way. But you can. It's so this isn't like when you configure this and when you stand this up, this chaos engineering and the chaos studio and the chaos mesh. You can do what one of the slides said earlier about limiting blast radius, because you have to set specific permissions. You have to set specific namespaces and privileges to Chaos Mesh, to Chaos Studio, and even to Cube Invaders, as you've seen earlier, um, to limit that blast radius and to start small and build up. But yes, if
Precisely,
when you're starting
precisely.
out with all of this stuff, I suggest you definitely read the docs.
I think when you start playing around with it and then you get these frustrating messages like you don't have permissions and you're like, I have a contributor role myself. I do have permissions, but it's not about that. It's like about giving it permissions to disrupt the
Yep.
specific resource.
And one of the things I won't show you here, because the rule based or the IAM access control stuff has other user accounts in it that I don't want to show you. But
Hmm.
if you think about when you create an experiment, as you'll read in the docs, that experiment is almost treated like a managed identity. You have to assign that experiment permissions to your cluster or to
Mm,
whatever resource it is you're looking to experiment on. So it's
mm,
important to remember that it does treat it like a managed identity or a service principal. So you have to assign those permissions accordingly.
mm. Great. Cool. I think that was really cool illustration of Azure Chaos Studio. And while it's free, an additional benefit is, or like while it's in preview, an additional benefit is that it's free to experiment with. So I think it's gonna be free, or like in preview at least until January, if I'm not mistaken, January 2023. So do give it a try.
Yeah, definitely get experimenting and see. the entire point of this, as we've said a couple of times, is to help you, to give you this. These were very simple demos, but it's to give you a taste of what you can accomplish if you just start to introduce a little chaos into your software engineering and your platform engineering mindset.
Mm, mm. Yeah. So, what do you think, Carl? Have we been able to both try to disrupt the Christmas in Kubernetesville, but also find out how we can stop that Grinch?
So I think we there was definitely a lot of disruption happening from the Grinch, but I think making smart decisions and intelligent decisions when you're designing your applications, using multiple replicas, using multiple regions, making smarter architectural decisions and designing for failure, um, that helped us save Christmas.
Definitely. This story had a happy ending.
Yes, it did.
Cool. So I guess we are closing in on our session today. We would like to say thank you everyone watching us and watching this session. On the left hand side, you can see the QR code that we have created that would give you access to the GitHub repo where we have all of our resources. Carl, you also have added the resources for Azure Chaos Studio demo as well, I guess.
I have indeed. Yep. So
Yep.
you'll find separate folders in the GitHub repo with just basically the demo title for what we were doing today, and inside that you'll find the Terraform and the YAML and all of the stuff that you need to get started on your chaos journey.
Hmm. Awesome. And there is also a list of the relevant resources to some articles and blog posts and demos or videos that you could refer to learn more about chaos engineering and Kube Invaders and Azure Chaos Studio.
Awesome.
All right.
Thank you very much,
Uh,
Kristina. It was fun doing this session with you. If you want to learn more about what Kristina's up to and follow her journey as an MVP and all of the good content she puts out, do follow her on Twitter, connect with her on LinkedIn, and check out that GitHub profile.
Thank you, Karl, and likewise for Karl. So for me it has been the first time I'm running a session with another speaker, and it was huge fun to do that with you, Karl. It's a big
E-
pleasure collaborating with
Even
you
when Miss
on.
Four decided to visit in the middle of that a couple of times. So,
I think that makes it even more cozy and festive. I think this just
yeah,
shows that we are human and we have families, and that's how you do that when you are working from home, for instance. So that
yes,
was just a huge pleasure to meet her today. So if you would like to follow Carl and all the awesome content that he puts out, and also get quick access to his LinkedIn course because he just published the news yesterday or the day before yesterday, I think. So it's very, very fresh. Or like for you, it will be in December, but still, it will still be really fresh. So
still
do
fresh.
ensure to follow him on Twitter and LinkedIn and GitHub.
Awesome. Well,
All right. Shall we
that was
wrap this
awesome.
up?
Thank you all for tuning in, and we're going to wrap. Have a good Christmas and Happy New Year.
Thank you. Have a good Christmas and Happy New Year. Bye.